Hello all, welcome to the video on Structured Query Language or SQL. In this video, I am going to give an introduction about SQL. Before starting SQL, let us discuss what is Relational Database Management System or RDBMS. What is data? Data is a collection of characters, numbers, or symbols that represent some facts about an object. For example, your name, age, mark, height, all these are data about you. Then what is a database? A database is a systematic collection of data. If we are arranging all this data in a systematic way, such a collection of data is called database. In a program, data will be coming from different sources to an application, and this data should be stored for processing or for future use. So, database is a collection of data. DBMS or Database Management System is a software to create and manage databases. In order to manage these databases, we need a software, and such software is called a DBMS. After storing this data, we need to retrieve or manipulate this data. Retrieving data from a database through special type of commands is called querying the database. We are submitting some queries and answers will be returned from this database. Then next we can move on to RDBMS or Relational Database Management System. A relational database is a database in which data is stored in the form of relations, also called tables. In a relational database, there will be more than one table or relations in it, and all these relations will be linked each other with the help of a particular column. Next, we can look what is RDBMS. A DBMS used to manage relational databases is called an RDBMS. We have already seen that DBMS is a software used to manipulate database, and an RDBMS is used to manage a relational database. Examples of RDBMS are MySQL, Oracle, SQL Server, PostgreSQL, MongoDB, etc. Let's look one example for RDBMS. Here I have given a database name library which consists of two tables, book and member. The details of book in the library are stored in this book table, and in the member table, the details of the members are being stored. In RDBMS, a table is also referred to as relation where data is arranged in rows and columns. Here in this table, two tables, book and member, data is arranged in rows and columns. Each row consists the details of a particular book, and each column, here the bname column, consists of the names of book in the library. These two tables are related to each other with the help of a common column code. In both tables, we can see a common column code. When we look into this member table, the member M101 Raghav Sinha has taken the book code L102 on this particular date. If we want to know which book he has taken, we can look into this book table and we can see that the code L102 here and the book is Germany. So these two tables are related with the help of a common column. Such a database is called relational database, in which the tables in the database will be related to each other. The columns of a relation are called attribute. Attribute are the columns in a table. The attributes in the book table are code, bname, and type. Here in the member table, MNO, mname, code, and issue date are the attributes. And the rows of a relation is called a tuple. So F101 priest fiction is the first row. L102 Germany literature is the second row in this book table. And M102 Anisha Khan C101 and the date 2016-16 is the last row in this member table. The rows in a table is called a tuple and the columns are called attribute. The next term is cardinality. Cardinality is the number of rows or tuples in the table. We can count that there are 1, 2, 3, 4 and 5 rows in this book table. So the cardinality of this book table is 5. And the cardinality of the member table is 3 since it contains 3 rows. Cardinality means number of rows in a relation. And next term is degree. Degree means the number of columns in a table. Here in the book table, there are 3 columns, code, bname and type. So the degree of book table is 3 and the degree of the member table is 4 since it contains 4 columns, MNO, mname, code and issue date. So we have learned what is an attribute, tuple, cardinality and degree. Next, we can move on to structured query language or SQL. In order to manipulate these data in a database, we have to learn a special language. This special language is called SQL, structured query language. It is a special language which provides statements for defining the structure of the data, manipulating data in a database, declaring constraints, and retrieving data from the database in various ways. Using this language, we can create a new database or change the structure of the table, retrieve data from the table. We can look what are the characteristics of SQL. It is very easy to learn and use. Large volumes of databases can be handled quite easily. It is a non-procedural language. That means we need not to specify any procedures to accomplish a task, but we are giving a particular command to perform that activity. Such commands are called queries. Querying a database. We are providing some queries and the result will be displayed. SQL can be linked to most of other high-level languages that makes it first choice for database programmers. It can be linked with other languages like Python, Java or C++ to store the data from the program. Next, we can move on to data types of SQL. The first one is numeric data type, which is used to store numbers. The first numeric data type is integer or simply int. This data type is used to store whole numbers. Here the argument size denotes the number of maximum digits that can be stored in that column. The next data type is float, decimal or double, which is used to store decimal numbers. Here m, d means that values can be stored up to m digits in total. That is, in total there will be m digits, of which d digits may be after the decimal point. Total number of digits is denoted by m, and out of that d will be in the decimal part. We can look at an example. If we are defining a column as float 7, 4, there will be a total of 7 digits. It's 1, 2, 3, 4, 5, 6 and 7 digits will be there, out of which 4 numbers will be in the decimal part and 3 in the integer part. That is, we can store up to 999.9999. Then second data type is string or text data type, which is used to store characters. Two data types are there, char and varchar. The maximum number of characters can be stored is passed as argument to these data types. The difference between char and varchar is that char is of fixed length, whereas varchar is of variable length. For example, I am declaring a column as char 6. It is of fixed length. That is, MySQL ensures that all the data entered in this column have this length 6. Even if I am entering a small data like Anu, the rest of the data will be utilized by adding blank spaces. The maximum length of this column is 6. Even if the data is shorter, then blanks are added to that place. If I am using varchar 6, varchar data type is of variable length, each value that is stored in the column stores exactly as you specify. That is, it will not add any blank spaces as in char data type. In both the cases, if you exceed the maximum limit, an error message will be displayed. So char data type is of fixed length and varchar is of variable length. String data in MySQL should be enclosed in double or single quotes. Third data type is date, which is used to store date in the format YYYY, MM, DD. The date values also should be enclosed in single or double quotes. So these are the main data types available in SQL. Next, we can move on to types of SQL command. First one is DDL or data definition language. This DDL statement allows you to perform tasks related to data definition, like create the structure of the table, modify the existing structure of the table, or remove the tables. These DDL commands are used to create, modify, or remove a table in the database. Examples of DDL commands are create table, alter table, and drop table. Second one is DML command, data manipulation language. DML commands allows you to access or manipulate data in the existing tables. So DML commands manipulates the data in the tables. The manipulation includes inserting data, that is, we can add new data to the table, or deleting data from the table, modifying the existing data, and retrieving the data. DML commands include insert, delete, update, and select. We can insert new data, delete the existing data, update data, or select, that is, retrieve data from the table. So mainly there are two commands, DDL and DML commands. DDL commands allows you to perform tasks related to data definition, and DML commands allow you to perform data manipulation, data definition and data manipulation. Two more commands are there, DCL and TCL. DCL means data control language and TCL is transactional control language. DCL commands are used to control the transaction commands like commit, rollback, and save point. And transactional control language is used to manipulate permissions or access rights to table commands. We can grant or revoke some rights to a table or database. Such commands are included in this transactional commands. And data control language is used to control. That is, we can permanently save a command by using the commit command, or undo the previously executed command using rollback. Such commands are defined in this DCL command. The main two commands are DDL and DML. Okay, let's move on to the next topic. Next topic is constraint. The word constraint means certain conditions. The constraints can be used to apply some restrictions on the data values that an attribute can have. For example, an attribute called mark should have only marks from the range 0 to 100. If we are entering a mark greater than 100, an error message should be displayed. So we can restrict the data in a particular column with the help of some constraints. These constraints come into play whenever we try to insert, delete, or update a record in a relation. Mainly there are 5 constraints: not null, unique, default, primary key, and foreign key. These are the main 5 constraints that we can apply to an attribute in a table. We can look one by one. The first one is not null constraint. This constraint ensures that we cannot leave a column as null. That is, we have to specify a value to that column. For example, a column named name, which is of type varchar 25, we are applying a constraint not null. We can define these constraints at the time of table creation. While defining a particular column, we can specify the constraint for that column. Here in this example, the name column is applied with a not null constraint. Second one is unique. Unique constraint means that the values under that column should be unique. That is, there should be no repetition in that column. For example, a column named phone of char data type is applied with a constraint unique. So, no 2 rows in that table can have duplicate phone numbers. The phone number should be unique for each rows in that table. Next one is default. This is used to provide a default value for a particular column. This default value will be used when the user does not enter any value for that column. That is, if we are skipping value for a particular column, the value provided as default value will be supplied for that row. For example, the date of birth column, DOB, with data type date, we are specifying a default date of birth as 2001. So if we are skipping the date of birth of a particular person, this default value will be provided to that person. Next one is primary key. This is an important constraint. The column which can uniquely identify each row or record in a table is called primary key. Primary key is used to uniquely identify rows in a relation. There are certain conditions that we have to follow if we are declaring a column as primary key. It must contain unique values and cannot contain null values. The two constraints, unique and not null, are combined together in this primary key constraint. For example, roll number, data type int3, and we are applying the constraint primary key. The roll number of all the students should be unique and the roll number cannot contain null values. Each row should be provided with a roll number. It is almost similar as unique key, but there are differences between unique and primary key. The first difference is that primary key is used to identify a row or a record in a table because there will be no duplicate values. If I am specifying roll number 10, there will be only one student with roll number 10. So this primary key column can be used to identify a particular row in a relation. If we are specifying a name as Jibin, there will be more than one Jibin in that table. So we cannot use other columns to identify a particular row, but the primary key column is used to identify a particular row in a relation. Unique key is used to prevent duplicate values in a column. Second point is a table can have only one primary key. If I am defining roll number as a primary key field, no other columns in the table can be declared as a primary key field. There can be only one primary key in a relation. But for unique key, we can have multiple unique key. If I am declaring phone number as unique, I can declare a column named Aadhaar number also as a unique key. So a table can have multiple unique keys. Then the third difference is primary key does not accept null values, but if you are declaring a column with unique key constraint, it can have null values. Primary key does not accept null values, but unique key accept null values. These are the three differences between primary key and unique key. Primary key is used to identify a row in a table. Unique key is used to prevent duplicate values in a column. A table can have only one primary key, whereas a table can have multiple unique keys. Primary key does not accept null value, but unique key accept null values. These are the three differences. Then the fifth constraint is foreign key. A foreign key is used to represent relationship between two tables. We have already seen that there will be multiple tables and these tables will be related with the help of a common column. The foreign key constraint is used to represent the relationship between two or more relations. Foreign key is an attribute whose values are derived from the primary key of another relation. So there will be two tables, table 1 and table 2. Table 1 will contain a primary key column and this primary key column will be referred as foreign key in the second table. The values in this foreign key column in the second table will be derived from the primary key column of the first table. For example, I have declared a custody of type varchar5 as foreign key in a table. This custody is referred to the parent table master. These two tables are related with the help of this foreign key. All the values will be derived from this primary key column. We cannot insert a value in this foreign key column which is not present in the primary key column of the parent table. So that's all for now. Let's do a quick recap. First we have looked what is data. Data means raw facts and figures, and database means a systematic collection of these data. Then we looked DBMS and RDBMS. Both are softwares which is used to manage database. RDBMS manages relational databases. Then we looked what is SQL. It is a language used to process these databases. Then after that we looked what are the data types in SQL. Int, float, char, varchar and date are the main data types in SQL. Then we looked what are the constraints. That is, in order to apply some restrictions to the data entered in a column, we can apply some constraints to a column. The constraints are not null, unique, default, primary key, and foreign key. Hope you have all understood this topic. Thank you.